Today, we're skipping the usual talk about solar and wind. We're doing a deep dive into sources that claim the next big thing in energy isn't about, big concentrated forces.
Right.
It's about harvesting the ambient energy that's literally all around us.
Yeah.
Some are calling it the new ether.
And it's a really important redefinition. When we say ether now, in 2025, we're not talking about some old, outdated physics concept.
Yeah.
We're talking about three specific domains. First, there's the electromagnetic noise floor, for the RF smog from our devices.
Okay.
Second, you have the kinetic flux of subatomic particles, things like neutrinos. And third, the fluctuations of the quantum vacuum itself, zero-point energy.
So if the last century was about filtering out noise,
Yeah,
our mission today is to understand the tech that's trying to capture all of it.
exactly.
We're going to unpack this term, the vacuum vortex nanomatrix. I've heard it described as an anti-radio. Is that fair?
That's a great way to think about it, yeah.
Yeah.
It's not trying to find one clean signal. It's
Yeah.
designed to grab the entire chaotic spectrum and turn it into power.
All right, so let's get into it. Where do we even start with a material like that?
You have to start with the foundation, the physical structure, which is the monolayer,
A single atomic layer.
a single atomic layer. When you get a material that thin, you maximize the surface to volume ratio. It's critical because it means every atom is
How
totally
to add
exposed.
sweetness to
So
your
every
life
atom
when
can
you want to
interact with
snack
these
or prepare
really,
for the
really
holiday
subtle
parties.
forces.
Don't forget this
It's not
cookies
just
for
about
you
saving
and
space.
your family.
It actually
They are
unlocks
so
new physics.
delicious.
It unlocks completely
Also,
new
these
properties.
cookies are
What's a good example?
keto-friendly
A material
and vegan.
that,
Each cookie
gets a
only has a
superpower
few
when it's that
grams of
thin.
sugar.
Molybdenum disulfide.
Perfect
Too.
for adding
In
a
its
little
bulk
bit of
form,
sweetness
it's
to
useless
your
for
life.
this. It's too symmetrical.
Useless how?
It's not piezoelectric. It can't turn mechanical stress into electricity. But when you get it down to a single monolayer, that symmetry breaks. Then the tiniest vibration, even just from the air around it, is enough to generate a small but harvestable voltage.
So then why all the focus on these hybrid perovskites? They sound a lot more complex.
It all comes down to sensitivity. The sources point to one in particular, a lead-free version called, and it's a mouthful, ATHP-2SNBr4.
Okay.
That monolayer is calculated to be 7 times more responsive than the stuff we use in our current microelectromechanical systems. It's like an ultra-sensitive microphone for the world's vibrations.
This is where it gets really wild for me. How do you take all that random jiggle, that chaos, and turn it into usable DC power?
That's the vortex part.
It's a vortex, right?
You need something to force a one-way flow. In these magnetic thin films, the vortex acts like a quasi-particle. It's called a skyrmion.
A skyrmion.
And when the skyrmion moves through an asymmetric pattern of tiny defects in the material, it experiences a ratchet effect.
A ratchet effect. So
Yeah.
like a one-way gear. It can move easily in one direction, but not the other.
That's it. That's the key. The random ambient energy pushes the skyrmion, but the structure forces it to move in one direction. It organizes the chaos into a directed current.
Okay, so this isn't just theory. The most visible and I guess most controversial attempt at this is neutrino-voltaic.
Very controversial, yeah.
What's the actual hardware they're using to supposedly catch neutrinos?
The core is a very specific multi-layer stack. We're talking 12 alternating layers of doped graphene and silicon.
But the big pushback from standard physics is that neutrinos barely interact with anything. They pass through the entire Earth.
Right, and that's the critique. The cross-section is tiny, but the proponents, they argue it's not a simple collision.
So what do they claim is happening?
They call it harmonic resonance. The idea is that the flow of neutrinos acts like a pump. It doesn't hit the graphene lattice, it just boosts its existing thermal vibrations.
And the silicon layers there too.
The silicon acts as the diode to rectify that energy transfer into a continuous current. They claim a small device, maybe the size of a tablet, could produce 3 watts, constantly, day and night.
So when you step back, what this all seems to mean is we're shifting our focus. We're moving away from big, concentrated sources like the sun and wind toward organizing the background noise of the universe.
It's a fundamental shift, and it provides real-world validation that the vacuum isn't empty. It's a turbulent, energy-rich ocean. It's the real modern ether.
An infinite fuel source, if we could figure out how to organize it.
If we can refine the tools, yes.
So here's a thought to leave you with. If we are really learning to engineer the fabric of space-time, even on this tiny scale, we have to consider the ultimate boundary. Theory suggests our vacuum state might just be medostable, stable, but not the most stable.
The false vacuum.
Exactly. And one intense, ill-conceived experiment could theoretically trigger a false vacuum decay, an event that would expand at the speed of light, rewriting the fundamental laws of physics as it goes. That's the ultimate cautionary tale for tapping the fabric of reality itself.